In this lesson, we're going to look at writing something that is in general form in standard form. And remember, standard form is y equals ax minus p squared plus q. And you might wonder why we want to convert something from general form to standard form. Well, when something's in general form, such as x squared plus 10x plus 16, it's not very useful. We can't look at that form of the equation and know the vertex, the axis of symmetry, any of that sort of stuff. So it's not a very useful form of the equation. So if we transform it into standard form, then we have lots of information we can look at that will help us analyze the equation. Now, completing the square is a process. It's a process of changing from general form to standard form. And step one says, take half the numerical coefficient of the x term and square it. Add and subtract the squared number in step one. And the reason we do that is it keeps the function the same. You'll see why in a second. And form a perfect square and write it in factored form. So we're going to go through this process with a couple of different questions, and then we're going to look at a couple more complicated questions for completing the square. If you're a little confused by the process of completing the square, what I would suggest you do is I would suggest you just watch the first example, watch what I'm doing, listen to what I'm explaining, and then stop the video and copy down everything that I've got there when it's done. If you have to, go back and rewatch the video. The same thing with the second example. Just watch the video, watch how I complete the square, then write it down. Another trick might be, if you think you understand how to complete the square with the first example, then what you do is you try to do the second example all on your own. And once you've done it and you think you're right, quickly scrub through the video and see if the solution you got is the same solution that I've come up with on the video. That's a kind of a way to help you learn the process. It would be something similar to what we might do in class. In class, I might ask or give you the first example and then ask you to try the second one on your own, and then we would go through it together. So you can do the same thing using the video. So if we take x squared plus 10x plus 16, the first step says take half of the numerical coefficient of the x term. So we take half this middle term, half of 10 is 5, and then it says square this number. Squaring 5 gives you 25. There's a reason we're going to write down 5 and 25. You'll see in our work in a minute. It says, then take this squared term and add it and subtract it from our equation. Now, if you add and subtract it, 25 minus 25 is just 0. You haven't changed the original equation. But why do you want to add and subtract 25 to the equation? Well, remember, we're trying to put this particular equation into standard form. And standard form has a factor in it, which is squared. That means two binomials that are exactly the same. If we look at these first three terms, if we look at that quadratic, that actually gives us, if we factor this quadratic, the factors of this quadratic are actually x plus 5 and x plus 5. And negative 25 plus 16 is going to give us negative 9. Okay, if you look at x plus 5 times x plus 5, that's the same as x plus 5 squared minus 9. So there we have this in standard form now. You could check and make sure if your standard form is right by graphing this form and that form on your calculator and see if you get identical graphs. That's a way to check. The other way to check is plug a value in for x here, and plug a value in for x in your original equation, you should get the same solution. Now, I said there was a reason we wrote down half the middle term, which is 5, and the 25. Reason we write down 25 is so we know what we're going to add and subtract to our equation. The reason we write down 5 is when you actually go to factor x squared plus 10x plus 25, we got x plus 5 and x plus 5. Well, the plus 5 is actually the same value as half of your middle term. So if you realize that, then what you can do is you can skip from this second step all the way down to the solution because you know what this squared factor is going to be. Okay, so as I said, if you want to, you can stop the video right now and you can try this second question, x squared minus 9x minus 20. You can try doing it on your own. See what you get. And then once you've got a solution, you've got something in standard form, play the video, scrub through it quickly, and see what you come up with in terms of what we've come up with here. Do they match up? If you don't want to do that, if you want to watch the video again, go ahead. I'm going to go through the example, but if you want to try it on your own, stop the video now and then continue to play it once you're done. So we are going to continue on. So remember the process. Step 1 says take half of the middle term. Well, half of negative 9 is negative 4.5. Is it okay to have a decimal? Absolutely, it's okay to have a decimal. Then it says square the negative 4.5. Well, if you square negative 4.5, it gives you 20.25. The next step says take this squared term and add it to our equation and subtract it from our equation. And don't forget that you also still have a negative 20. Lots of people forget to bring that down. Okay, remember, if we look at these first 3 terms, those first 3 terms are what are going to give us our perfect squared factor. And remember, our perfect squared factor is going to be half our middle term, and half our middle term is negative 4.5. Now if we take negative 20.25 minus 20, we get negative 40.25. So here is our equation. Now it says in the question, determine the minimum value of the function of f. Well, let's talk about this a little bit. This leading coefficient right now, the a value in our y equals a, x minus 4.5 squared minus 40.25, that a value is positive. And if you remember, from some of the work we've done with our graphs, if a is positive, our graph opens up, and if a is negative, then the graph opens down. So because a is 1, we've got a graph opening upwards, and it has a minimum value because our vertex is the lowest value on the graph. Now remember, minimum and maximum values relate to the y value. That minimum value is the minimum value at our vertex. So in this case, our minimum value is going to be negative 40.25 because our vertex in this case is 4.5 and negative 40.25. And when we look at our vertex, that minimum is always the y value of the vertex. Now, the first 2 examples that we looked at had quadratics that had a leading coefficient of 1. But we know not every quadratic in the world has a leading coefficient of 1. So if we look at questions where you do not have a leading coefficient of 1, we have to add in another step. What we have to do is we have to use the coefficient of the x squared term as a common factor of the x squared and the x term only. And then the rest of the process is the same. So I'm going to show you what that looks like. Well, how do we do that? So if we look at this particular equation here, it is y equals 3x squared minus 18x plus 20. It says take out the coefficient of the x squared term from the x squared and the x. So basically what you're doing is you're taking out a common factor of 3 in this case. When you divide 3x squared by 3, you're left with x squared. When you divide negative 18 by 3, you get negative 6x. Now, leave some space. You're going to see why. We're going to write some things in there in a second. And we write the 20 outside our brackets because we did not take out a common factor of 3 from the 20. The reason we didn't take out a common factor is in a moment, we're going to move some values that are inside the brackets outside the brackets. Well, if we took a common factor out from 20, it would be inside the brackets. And when we moved it outside the brackets, we would end up multiplying it by 3, which you'll see we're going to do in a second. And so you're essentially doing and undoing some work. So that common factor of 3 only comes out of your x squared and your x term. If you need to watch this whole example, then write it down, then go back and rewatch the example, do that. So the new step so far is taking out a common factor from the first two terms. Now the rest of the process is the same. We take half the middle term. Half of negative 6 is negative 3. And we square negative 3. Well, if you square negative 3, you get 9. So we're going to add 9 and subtract 9 to our equation. Now, our leading coefficient is 3. Our squared factor, which is made up of those first 3 terms, is going to be x minus 3 squared because half the middle term is negative 3. Now, this 9, we need to move this 9 outside the brackets because we need to add and subtract it with 20. But everything inside the brackets is affected by this 3 in front. So we have to go 3 times negative 9, which is going to give us negative 27 plus 20. So our final equation is x minus 3 squared minus 7. So there it is in standard form. Now, it says determine whether the graph of the function has a minimum or a maximum and state that value. Well, if we look at this leading coefficient value, that's positive. And when that's positive, that means our parabola opens up. And when our parabola opens upward, that means we have a minimum value. The lowest value occurs at the vertex. And what is that lowest value? Well, the minimum value is always the y value of the vertex, which in this case is negative 7. Okay, so as before, if you think you understand this process, try the next example all by yourself, then play the video and see if you actually get the correct solution. But I'm going to give you one hint here. Before you try this, you always need to rewrite your polynomial so the x squareds are first, the x's are second, and the whole numbers are third. So you have to rearrange this before you try it on your own. So if you want, stop the video, try it, and then play it. If not, follow along on the video. I'm going to go ahead and do this. So remember, we need to take out a common factor. In this case, the common factor is negative 2. And we need to take out that common factor from the first 2 terms. So 10 divided by negative 2 is going to give us negative 5x. We leave some space. The 7 goes outside the brackets. Now, half of the middle term, half of negative 5, is negative 2.5. And if you take 2.5 and square it on your calculator, you get 6.25. So we're going to add 6.25 and we're going to subtract 6.25. Okay, so now we still have negative 2. We have x minus 2.5 squared because half the middle term makes up our squared factor. We're going to move this negative quantity out because the first 3 terms were used to create our squared factor. So we have to take negative 2, which was in front, and we need to multiply it by negative 6.25. Well, that's going to give us 12.5, and we still have to add 7 here. So when we're done, we get negative 2, x minus 2.5 squared plus 19.5. So there we go. There we have this in standard form. Now, next part of the question says, what direction does the parabola open? Well, this leading coefficient is negative, so that means our parabola opens downwards. So we say it opens downward. Next thing it says, what are the coordinates of the vertex of the parabola? Well, remember the P and the Q are the coordinates of the vertex. So the vertex in this case, if we solve this for x, we get 2.5 as a value for x, and our y value is 19.5. So there we have it. Completing the square. It's not that difficult. One of the reasons we're going to have you complete the squares, we're going to then have, as we said, some really good information. We know what the vertex is. We know what the axis of symmetry is. We know what direction the graph opens. Makes it really easy to graph things. We're also going to use this standard form of the equation to solve some problems, some maximum and minimum word problems. So being able to complete the square is going to make it easy to solve those types of problems.